Okay, hello online learners. Today we're going to be learning about scales. So, the term scales can refer to many different things, including instruments for weighing or the protective skin coating on a fish. In this lesson, though, scales are the measurement marks placed at precise intervals on scientific equipment. In the science laboratory, you use measuring devices that include scale markings. Oftentimes, you may use these measurement scales without really thinking about how important they are. But in scientific research, scales are essential to obtaining precise results. In this lesson, you will learn how to accurately read a scale on a piece of scientific equipment. You will also learn how to use scales to make precise measurements. So we're going to learn how to recognize the smallest gradations on a scale, use scale to arrive at precise measurements, and describe the difference between accuracy and precision in measurements. So accuracy is an indication of how close a measurement is to the correct result. Gradation is the scale markings that denote equal units of measure, and precision is the degree to which a measurement can be replicated. So, by the way you record a measurement, you can tell others something about the precision of the instrument you are using. Take a look at the following ruler. Okay, so this is a ruler. The big blue marks are the centimeters. The little yellow marks are the millimeters. Remember, every centimeter has 10 millimeters. So if you look here, you can see that there's 10 marks. We start at 0 and we have 1, 2, 3, 4, 5. That's this long line. 6, 7, 8, 9, 10. Okay, there's 10 millimeters in every centimeter. Okay, the smallest gradations on this ruler are millimeter markings. So this is a gradation. This yellow mark, every yellow mark is a gradation. Every blue mark is also a gradation, but the smaller marks are the millimeters, and the bigger marks, these big blue ones, are the centimeters. Okay, this means you can measure precisely down to the millimeter level. It has been agreed upon in the scientific community, however, that when using a calibrated scale, you should estimate 1 digit beyond the level of the markings. Using the ruler above, this would mean you should estimate to 1 digit beyond the millimeter level, or 0.1 millimeters if you are recording your measurement in millimeters. If you are recording your measurements in centimeters, you should estimate to 0.01 centimeters, or to 2 decimal places. Okay, so it says how long is the line in centimeters. So here's our line right here. We're going to click to zoom because it wants to know centimeters. So our line comes right after the 2 centimeter mark right here to one place, maybe even a little bit in between that first and second millimeter mark. Okay, so it wants to know centimeters. How many centimeters? Centimeters are these big numbers. So we know it's at least 2 centimeters. It's a little bit more than 2 centimeters. So here's our possible answers. It could be, is it 2.1? Is it 2.10? Is it 2.13? Is it 2.15, 2.2, or 2.20? So let's look at it again. It looks like it's in between 2.1. This would be 2.1 right here, and 2.2, right? It's like it goes a little bit in between. So let's say 2.15, because that means it's halfway in between 2.1 and 2.2. Okay. It says there are actually 2 correct answers in the list, as long as the reading has 2 digits after the decimal point, because the gradations are at the millimeter level, and it is larger than 2.1 and smaller than 2.2, it is valid. The variability is allowed because people estimate differently. This means that 2.13 and 2.15 could both be correct. I didn't realize 2.13 was an option, okay? Because if you look at our ruler, it does, I guess it could be 2.13. You don't really know because you can't see that close, but so it could be 2.13 or it could be 2.15, somewhere in between there. So that's why it's saying either of those answers would have been correct. Okay, here's another one. Okay, record the length of the line shown in centimeters. Okay, so here's our line. Looks like we're coming right after the 5 centimeter mark. And we're going right there. It looks like about maybe 5.6. This one looks like it's pretty much on the 0.6 mark. Because here's what, this would be 5.5. So this looks like 5.6. Right there, 5.6. Okay, so it says, since this line ends right on a gradation, meaning right on the mark, it seems to need no estimation. It appears to be exactly 5.6 centimeters. So, how should you record the length? The correct way to record this reading is to indicate that this line is exactly, not almost, 5.6 centimeters long. Because you are measuring in centimeters and this ruler has markings for millimeters, you need to record your measurement to 2 decimal places. You do that by estimating the next digit to be 0. Therefore, the correct recorded measurement is 5.60. Okay. So we have to put that extra decimal point in, which gives us that 0 right here. Okay, accuracy. Now that you know what it means to make precise measurements, let's take a look at the meaning of scientific accuracy. In everyday language, the term precision and accuracy are often interchangeable. In science, they have quite different meanings. In this lesson, you have seen how the scales on instruments allow you to be precise. That is, help you obtain reproducible results. However, even if you do manage to consistently repeat your results, you still might not have the correct solution to the problem. Accuracy, then, is how close your result is to the accepted value for a given measurement. For example, let's say several students are given a new brand X thermometer. The students use the thermometers to measure the boiling point of water and get the following results: 85.2, 85.0, 89.4, 85.1, 85.2, 85.0, 85.3. The list is quite precise. Okay, that means that all of these numbers are right around 85, if you notice, okay? They're all around 85. They're not 80, 83, 86, 87. They're all around right around 85. This list is quite precise. All the readings cluster tightly around 85.1 degrees centimeters. Celsius. The problem is that the known boiling point of water at sea level is 100 degrees Celsius. Therefore, these thermometers are not very accurate. There are reasons why water would not boil at 100 degrees Celsius, but in open containers, the readings should not be off by 15 degrees Celsius. These thermometers probably need to be sent back for a refund. Okay, so the boiling point is 100 degrees. So there's no way, if they were to be testing these thermometers out, the thermometer should read 100 degrees, not around 85. So the measurements that were taken with the thermometer, they are precise because they're all around the same number. They're all around 85 degrees. However, it's not an accurate thermometer because we know that the boiling point of water is 100. Okay, continuing. There are many reasons that accuracy is not maintained in an experiment or when reading instruments. Human error is a leading cause, and to avoid this, it is advisable to take repeated readings. Another source of error is instrument error. If an instrument being used to measure is not calibrated correctly, the measurements may be skewed in some manner. As in the above example of the thermometers, most manufacturers do calibrate the instruments before they sell them. But it is important to check the accuracy of the instrument you use before using it against an instrument that is known to be accurate. The third common source of error is method. If, for example, you and your lab partner are taking measurements and each using a different method or different instrument, you may get inaccurate results. Okay, so in review, we've learned the value of looking closely at the gradations on a piece of laboratory equipment. The readings you record will tell others about the precision of the instrument you are using. The place value of the last digit in the recorded measurement reveals the level at which you are estimating the measurement. The smaller the unit of the measure, the less variability is likely between readings. Scientific accuracy is not just a matter of precise results. Accuracy is obtained by comparing experimental results to an outside standard, if one exists. In those situations in which an outside standard is missing, the scientist must rely on a high degree of precision as an indication of accuracy. It may take many years of further experimentation by others and the use of other methods to confirm or deny precision-based results.